Hey guys, so today's lesson we're going to be looking at graphing secant, cosecant, and cotangent, the reciprocals of sine, cosine, and tangent. So I actually use this technique right here where to graph cosecant and secant, I lightly sketch the sine or cosine function using, the information from the equation, etc. I'm going to show you that technique because that technique is what I like to use. So on cosecant, what would we do? Well, first of all, the x values, of our graph is going to be the same as, so the reciprocal of cosecant is sine, right? The x values are going to be the same. We're going to have our pi over 2, we're going to have pi, 3 pi over 2, and 2 pi. Those are going to be the same. And we're also going to have the 1 and the negative 1. Those are the same as the sine graph. So we're going to graph the parent right now. So what I'd like to do is I like to do like a little shadow graph of sine, and I'll show you why in just a moment. We know that sine starts at the origin, right, and it comes up like this, down. So I just do like a little dotted line, little guy, because it is tremendously helpful for me in determining where everything goes. So I do the little dotted line. I have a little dotted line sine because, of course, that's the reciprocal of cosecant. Wherever sine crosses its sinusoidal axis, so in this case the sinusoidal axis is the x-axis, but we know from transformations from yesterday it moves, right? It can move up or down, whatever. But whenever it crosses its sinusoidal axis, that's where there's an asymptote for cosecant. Well, why? Because if sine is 0 and I flip 0 upside down, it's undefined, right? So I'm going to have an asymptote here when sine is 0, here, and here. So it helps me place my asymptotes quite easily. In addition, it also helps me draw the little, they kind of look like parabolas, but they're not parabolas. So I would basically draw this like reflection right here. That's where my cosecant would be, and here. Now I've been asked the question, well, does this actually equal -1 and does this actually equal 1? Yes, because let's think about the unit circle values. We know that sine of pi over 2 is 1. So the reciprocal of 1 is 1, right? So cosecant of pi over 2 is 1. So it actually is 1 and then it goes up. Notice how the reciprocal doesn't exist in the middle right here where sine is. It doesn't exist in there. It basically goes outward from its reciprocal. So that's really helpful to me in determining where to put the asymptotes and which way to, does it go up, does it go down, which one, is which. It gets kind of confusing for me. So that has been very helpful. Some students really don't like that little dotted line, and if you want to erase it, just erase it. By all means, just get it out of there. If you don't want it to stay there, just erase it. Okay, so that is how I graph these two, actually, cosecant and secant. So let's do the same technique. We're just graphing the parents right now. Do the same technique for secant. So my numbers here along my x-axis, are the same as cosines. We have the pi over 2, the pi, the 3 pi over 2, and the 2 pi. Those are the same. Again, my y values are the same. I have the 1 and the -1. That's all the same. Now I'm going to lightly, dotted line my cosine graph. If we recall, cosine starts up, right, and then it goes down. And so I'm going to do a little dotted line graph. And there is where okay, and then this is down too far. Okay. All right, so we're going to do the same thing. Now when cosine is 0, at pi over 2, we know that its reciprocal secant is going to be undefined, right? Because when 0 is flipped upside down, that's undefined. So I'm going to have an asymptote here and here. Okay. Then we have this part in the middle, pretty straightforward, pretty easy, so I would just graph that here. Now I'm only graphing one cycle, right? One period. That's all you really need to do. I'm not going to have you, go crazy and graph 2 or 3 different cycles. That's one is enough. These are little half. Okay, so it looks like a parabola. No, these are little half parabolas right here. It's going to go like this, and it's going to go like that. Okay. Now, if that really troubles you, you don't want to cut that in half. You certainly could extend it on both sides, but then you would be graphing more than one period. Okay, and so this is what secant looks like in its standard parent form. All right. Now, cotangent, unfortunately, I can't really graph the shadow of tangent, and it doesn't work for cotangent. It only works for cosecant and secant. Cotangent is its own little guy. So I'm going to, we'll graph it. I'm going to remind you about tangent. Remember we looked yesterday, tangent was like this, and he, like his middle part, like his, I think of it as like his little belly, right, is right on the origin. It's right here, and then he goes like that. Remember, this was negative pi over 2, and this was pi over 2. Okay, cotangent is quite different. Cotangents, so we say tangent starts at negative pi over 2 and goes to pi over 2. Or it's one cycle. Cotangent actually starts at 0. Its asymptote is at 0, which actually makes him easier to move around. Tangent probably, to me, is the hardest one to transform and move around because it's his middle that's at the origin, not like his side. Like this one, see, the side is at the origin, but this one, his middle is there, so it just makes it a bit harder. But for cotangent and tangent, we have to remember that the normal period is pi or 180, unlike our little friends of cosecant and secant, who is 360 or 2 pi. So to go completely out, we would go out here, and this would be pi. I'm going to erase my little tangent friend here. Okay. So, and at pi, there's an asymptote. So cotangent starts and ends with an asymptote for one period. Then we have the center, where this little center would be, which is, again, we're going to half it, right? We just half pi, so half of that would be pi over 2. And then we half each one of these, right? So we have pi over 4 and 3 pi over 4. So cotangent's middle is in the middle. But cotangent, unlike tangent, recall tangent shape went like this. Cotangent has the reverse of that. It actually, let's do our 1 and negative 1. So it actually starts over here up. At pi over 4, it's at 1. And then it goes to 0. Then at 3 pi over 4, it's at negative 1. So it looks like this. Okay, so it's really, tangent and cotangent are similar, but I can't really build one off of the other like I can on secant and cosecant. Okay, are we all right with that? So, questions on any of this so far? All right, then let's go ahead. We're going to have some examples on the other page that we're going to work through. So let's go to the second page. Now, the first one, I'm going to do the second technique I showed you yesterday. Recall where I plot the phase shift, then I find all the x values, then I find all the y values, and then I write it. Okay, I'm going to do it that way. Number 2, I'm going to do where we transform the points, like I showed you, the very first one I showed you yesterday. So I'm going to do one of each today. So let's start with number 1. Okay, so number 1, our phase, it's a minus 20 degrees, so we go right 20 degrees. And the phase shift always starts off our graph. Okay, unless it's tangent, right? Tangent is the weird one. On all the other 5, the phase shift starts the graph, and then we move to the right. Okay, so I start at 20 degrees. I need, it says, identify all transformations. We're used to that meaning by saying stretches and stuff. Really, it just really wants you to identify what the amplitude is. The amplitude is 3. B is 5. So our period is going to be, what are we in? We're in degrees, so 360 divided by 5, or the period is 72 degrees. Our C value, our shift is a positive 20 degrees, and our D is 6. So that's just, and then it is a reflect. That's really all they're asking us to do, is just to kind of jot those things down. All right, so our period is 72 degrees. So what do? I have my 20 degrees. I'm going to add 72 degrees to that, and that's going to give me my end of the 5 values you have to have on your x-axis, and that's 92 degrees. And so then so that we're in like step 2. That was step 2, where I add the period on. Step 3 was where I split it in half, right? I'm going to split this in half. So half of 72 is what, 36? So I would add 36 to 20, and then I would get 56. And then we split it in half again. So half of 36 is what, 18? So I would add 18 to 20, and that would give me 38. And then I would add 18 to 56, and that would give me 74. Okay, so I've gone through steps 1 through 3 from that second technique I showed you. I have all the x's lined out. Now I need to work on the y values. I start with how it shifted. It shifted up 6. So that's going to be, like right here, that would be where its sinusoidal axis would be. If I was drawing one, it would be at 6. My amplitude is 3. So then that means I have to go 3 above and 3 below. So 3 above 6 would give me a 9, and 3 below 6 would give me a 3. So my axes are set. Once I get that set, I'm going to draw my shadow cosine, right? Because this is secant, and I'm going to draw my shadow cosine. Now keep in mind, this is a negative secant. So a positive cosine would look like this, right? Just like a U. A negative cosine would be flipped, right? It'd be upside down. So the negative cosine would look like this, right? So I'm going to start here and put my little points for my upside down cosine. I'm going to draw my upside down cosine. Now, wherever it crosses its sinusoidal axis, which is moved, right? In the parent, it was on the x-axis, but now it's at 6. There's going to be an asymptote there. So I'm going to have an asymptote right here, and I'm going to have an asymptote right here. We have our little piece right there, and then our other pieces look like this. And there's our graph with that second technique I showed you yesterday. Now, a lot of students have been making this mistake, and I want to try to caution you against it. We are so used to using the y-axis that students have kind of just accidentally put that in their drawing, and they have like 6 values, and they're like, oh, I have more than one cycle. Well, you would if you're going outside of where we set. We said it was between 20 and 92. We don't go that way, we don't go this way, we just graph one cycle. Okay, so we don't really are using this, although, I mean, some students want to. It's just a habit, I think. But just remember, we just start where the phase shift starts on this technique. All right, for number 2, I'm going to use the technique where we transform points. So I'm going to use that one because some of us like that one. I'm going to write down all this information first, the A, B, all that stuff. So let's do that first. So for this particular one, our amplitude is 7, B is 8, which means our period would be, so we're cosecant, and we're in radians, so we would be 2 pi over 8, or what, pi over 4. Then our shift, our C value is, we're going to go left pi over 4, and our D is up 3. So there's the little transformations they're talking about. All right, so now I'm going to transform points. So let's write down the parent points for cosecant. My x values are the same as, sine. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Same x values. Let's think about, since sine is the reciprocal of cosecant, let's think about sine. Sine is 0 at 0, so that means cosecant is going to be undefined there, right? We'd flip it upside down, so we just put UND, undefined. At pi over 2, sine is 1, so the flip of 1 is 1. At pi, sine is 0, so this one is also undefined, or there's an asymptote there. 3 pi over 2, sine is -1, so we flip it upside down for cosecant and we get -1. And then I think you get the picture at 2 pi, we'd be undefined. Now the transforming points. Okay, the great thing about I do y values first because they're easier. Undefined is going to stay undefined. I mean, there's nothing to do to that. So that's going to be undefined, undefined, undefined. I mean, there's nothing to do there. For the 1, what do? We first multiply first. We multiply 1 times 7 and get 7, and then we add 3, and that gives us a 10. Okay, then we take the -1, multiply it by 7, gives me -7, add 3, that gives me a -4. And I have my y values. Okay, now let's work on the x values. They're typically a little bit more challenging, especially with radians because we have all those fractions. So the middle two affect the x, and they're always opposite, unfortunately, right? So I have a 0. I'm going to divide 0 by 8. Thankfully, it gives me still 0. And then I'm going to subtract pi over 4. So my first x value is -pi/4. I take my pi over 2, I divide by 8, which is multiplying by 1/8, right? I get pi over 16. Pi over 16 minus pi over 4. Yes, fun with fractions, right? Pi over 16 minus pi over 4. We would get a common denominator. Do that, fun. We get -3 pi over 16. Okay? For pi, we divide pi by 8, which gives us pi over 8. Pi over 8 minus pi over 4. Now that's a much easier one to do, right? Pi over 8 minus pi over 4 is -pi over 8. 3 pi over 4. Multiply that by 1/8. I get what? 3 pi over 16. 3 pi over 16 minus pi over 4 gives me -pi over 16. And lastly, I have 2 pi. 2 pi divided by 8 is pi over 4, and pi over 4 minus pi over 4, yay, something easy, right? Pi over 4 minus pi over 4 is 0. Okay, so now what we're going to do with this, with the transforming points, is we're just going to plot those points. I mean, that's all we have to do, right? Just plot the points. So let's see, we're starting at -pi over 4. And on yours, I accidentally put this y-axis on the other side. So it'd be easier if you moved it or just ignored where you have that. Sorry about that. So -pi over 4. 1, 2, 3. So we have -pi over 4. We have a -3 pi over 16. -pi over 8. -pi over 16. And then we have our 0. Our y values, let's see, we go to 10 and -4. So at pi over 4, we have an asymptote. At -3 pi over 16, it's at 10. At -pi over 8, there's an asymptote. So that tells me this goes up. Then at -pi over 16, we're at -4. And then at 0, we have another asymptote, so it goes like that. So there's both graphing techniques there for you. The first one where we graph by the phase shift. The second one where we transform points. Hopefully you are finding one that you like, maybe sticking with that one and understanding that one completely. Yes? Because, okay, it's a good question, because I can't go to the middle. I can't go to the middle. I always go away from the middle. Always. So if my point, so we know that we have a high point and a low point. If my point is at the high point, I have no choice but to go up. And if my point is at the low point, I have no choice but to go down. I'm not allowed to go inside. Okay, they always go opposite. Okay? Yes?
Also, will the curve above the y-axis or x-axis always come before the curve below the x-axis?
So on sine, that's positive, yes. But when sine is negative, it will reverse.
Okay.
Yeah. So it just depends on the transformation. Okay? All right. So this last one, this cotangent one, I'm going to graph by the phase shift method. I'm going to do the phase shift, like this first one. Okay, I just need, do we all have the points that we need? I need a little bit of room. Okay. So let me get a little bit of room here. Come on. All right, so let's collect our data first. Our, it's really not an amplitude for tangent, but we'll call it an amplitude. And cotangent is 9, B is 18, so that means our period, now remember it's cotangent and this is degrees, so the normal period is 180. The normal period is 180. I've caught myself several times putting 360 just because of habit, so just make a little note. You might even want to circle all the cotangents and tangents and write it before you even start your work, just to make sure that you don't make the mistake that I do, a lot of people do. So that period would be 10 degrees. Then our phase shift, our C value, I'm going to go right 20 degrees. And then our D value, I'm going to go down 5. So I'm going to do this by the phase shift method. So I'm going to go to 20. That's where I start. It's cotangent. It starts with an asymptote. Cotangent starts with an asymptote at 20. I take my 20 degrees and I add the period to it, 10 degrees. So I go out here to 30 degrees. And it ends with an asymptote. Okay, cotangent starts and ends with an asymptote. I go to the middle. So the middle between 20 and 30 is 25. Right, and then I go to the middle of each of these. So the middle between 20 and 25 is 22.5. So 22.5. The middle between 25 and 30 is 27.5. Okay, we okay? Now I work on my y values. I'm supposed to be shifted down 5, so that's where its little belly is going to be at -5, right? It's all shifted down there. And I'm going to go ahead and just draw it. Okay, its little middle guy, the middle is at -5. Then we'll call it, it's not really amplitude, but the A value is 9, so I need to go above 9, so I need to say -5 plus 9, which would be 4, and -5 minus 9, which would be, what, -14? Okay, and that's where the other two cotangent points go. So here at 22.5, 4 would be my upper point because cotangent starts up and ends down. And then at -14, at 27.5, okay, my -14 is a little off. Then there's my other one. So now I can graph my little cotangent friend, and he looks like that. Okay? Cotangent is the opposite. Now, if that were a negative cotangent, what would he look like? He would look like tangent. He would look like tangent, yeah. He would look exactly like tangent, and you wouldn't be able to tell them apart if you just saw the graph. You'd say, oh, that's a tangent graph. Well, it could be a negative cotangent graph. Okay? All right.